there. Awesome. Fantastic. Hello, good morning. When I made that on Sunday afternoon, I didn't quite realize this screen would be so big. But hello, hi. Before I get started, my clicker is not working. Why is my clicker not working? Well, that is very astute. I can use just on this. Hello, I'm Joe. As Alex said, I'm a web engineering consultant. I also do silly things in my spare time. If you want to talk to me about anything in this presentation, have a look at those socials, email, website, everything. Generally, I like making stupid things. I really want to make a silly game at the moment, which is kind of like a Soviet-themed pull request simulator, where basically every day you have to review code, and if it's too bad and it goes in, it ruins the build, but equally if you're not reviewing enough code reviews, then your family ends up like starving, you have to make these horrible choices. It's called Changes Please, where just generally everything is awful the whole time. This may have been inspired by a job I had once. Also, if you want a game to play, there's one live on my site at the moment. It's called Katamari Node Modules. If you've ever played Katamari Damacy, it's a very similar thing, where basically you play a node modules folder, and your job is to roll around the world and try and grab packages and slowly get larger in the time. It's great fun. Okay. Age of Empires 2, just so I kind of have an idea of who I'm talking to, can you give me a cheer if you played Age of Empires 2? Okay, a fair few of you. If you haven't played Age of Empires 2, don't worry. You should still be able to get something out of this. Basically, Age of Empires 2 was a real-time strategy game released originally in 1999, which is a long time ago. And basically, you would take over commanding an army from a civilization like the Britons or the Greeks or the Vikings, not the Dutch, I'm very sorry. Even in all the expansion packs, they haven't added that yet. And basically, you would build up a base, you would build knights, you would go and rush your opponent and try and win. And yeah, that's the game. Now, if you're thinking to yourself, maybe you walk away from this talk, maybe you walk away from this conference inspired, and you're like, I'm going to go and make my own version of Age of Empires. I need to tell you that what I'm about to show you today is not a good way to do it. There are much better choices to make. If you were going to build a really good version of Age of Empires 2, you should really probably use a game engine. Game engines give you loads of stuff out of the box. They give you things like sprite collision, they give you pathfinding, they give you AI, they make it really easy to convert between screen space and world space. Even using them doesn't really exclude you from having it be on the web. You can export from Unity to WebGL. Great choice. You should also probably use some sort of typed language. If you're using Unity, something like C#, or in the JavaScript world, use TypeScript, because there's a lot of data going on. You can get a lot of runtime errors. And even if you do it with untyped JavaScript and you're building it with React, you should probably render it using a rasterized image. By that, I mean you should put it on a HTML5 canvas. You could either do that by drawing two-dimensional things, you could do WebGL, you could use something like Vuejs, which does a lot of like the heavy lifting for you. I did none of these things. I decided to start entirely from scratch. I'm only using just JavaScript, CSS, and React. No libraries, nothing else. And I wanted to see if you could render it all using the DOM, where every single tile is a DOM element, every unit is a DOM element, every building is a DOM element. And really, the reason why I tried to kind of choose this approach, because fundamentally, this approach was the most painful one. And I like pain-driven development. It leads you to interesting places. Let's have a look at Age of Empires 2. Imagine you're working at Ensemble Studios in 1999, and the UI developer comes up to you and gives you this mock-up they've built in whatever, Fireworks in 1999, maybe? Photoshop? And you're going to start breaking this down and go, OK, how am I going to build this? So there's kind of three main sections. We've got our toolbar at the top. where we've got, our resources in the top left, we've got our population, we've got what current age it is in the middle, and the buttons in the top right. Then we've got this gorgeous isometric view, which is really, this is where the fun is. This is where you can select units, this is where you can send stuff in different directions. This is where most of the fun is. And then down the bottom, we have a toolbar which kind of reacts to what you have currently selected. You can, if you have a unit, you can move stuff around. If you have a building, you can build units. And in the bottom right, you have a mini-map. So immediately, looking at this, there's a couple of bits which should be easy. There are parts of this which React was literally built for building UI, for building heads-up displays. So we can start doing that immediately. So this is my HTML Age of Empires 2. We've done it, gang. We've rebuilt Age of Empires 2 in React. Come on! We've got a nice ordered list. We've got some semantic buttons. What more do you want? OK, we can style it. That's fine. So this is rendered in the DOM using styles, where those are just buttons down the bottom. This is kind of a mixture of using background images for places. The border at the top, actually, of the bottom bar is entirely a CSS border, similar with a bunch of other things. But my favorite part of making this part of the thing was doing a custom cursor, which I haven't done since I had a GeoCities site, but it was wonderful to do. So we've got kind of our visuals now. That looks relatively Age of Empires-ish. So what do we have to do now? We want to make it react to things. It's the name of the framework we're building this in. So we're going to add some state. This is going to be quite complex state that we're dealing with. So using a use reducer is the best kind of approach. And this is the rough kind of shape that I'm kind of taking for storing things where we have an array of, an object map of units, and then an array of IDs, an object map of buildings, array of IDs, and then some extra UI things that we can slowly expand out about, like, what's currently selected, things like that. So if we just print all of that out in the center, and then we connect that to a couple of mutations that build some spearmen and updates it, we have text-based Age of Empires. There is a reason why RTSs didn't become a thing until graphics were at a certain point. Now, really, you could continue building out the functionality. At this point, we could add various different battling mechanics in this kind of text state. But I think I'd rather make it a little bit more interesting. So we're going to have a look at this isometric view. I'm going to try and render the functionality we currently have. So I'm going to want to be able to move a unit around. I want to be able to click on a building. I want to be able to, oh my. The gods are angry. I haven't done Age of Mythology yet. So we're going to try and render the stuff that we've already built in this isometric view. Now, I did play around with this idea of, like, could I do this entirely in the browser? Because you have everything that I've pulled from the game, which are these isometric assets. So they're all rendered like this. They're not like 3D objects that are then rendered in space. These are just good old-fashioned 2D sprites. This is a big shout-out, by the way, to Age of Kings Heaven Forum, which is where I got a lot of the tools which help me do this kind of thing. My favorite thing about using it is this website has not been updated since the 90s because they still reference download accelerators and download managers, which just make me feel nostalgic for the past. Now, on there, you can get a little tool which will help you extract out files from the Age of Empires original game. Unfortunately, it only runs on a Windows machine, so I had to get my Windows laptop out and run a bunch of stuff. And I managed to extract a bunch of assets. So I've got all these sprites. How am I going to render them? How are we going to do this? If we just put them in a flexbox and rendered them like this, we would get this bizarre checkerboard thing, which weirdly is kind of close, right? Like, if we were playing chess, this would be totally correct, but alas, we're not. So instead, how are we going to do this? I briefly tried trying to do this entirely in CSS transforms, because in CSS we have this wonderful stuff where you can rotate stuff and do it in 3D, where you can take this square grid and then shift it a little bit. We've got free isometric stuff. And I went down this rabbit hole for a while, but I had to take every asset in it, which was isometric, de-isometric it, import it into the game, and then render it, which felt like too many manual steps. And it was going kind of OK until eventually I started trying to render units like that. So I scrapped that idea, and I was like, OK, unfortunately, I am going to have to do some maths. I'm sorry, it is relatively early in the day for some maths. But we're going to have a look at an isometric grid. So if we think of the isometric grid like this, where you have an x-axis and a y-axis, and we're going to call this world space. This is kind of the general term for if you were in the world of Age of Empires and you were a unit on that grid, that is the space in the world you would be. If you were sat at the origin at the top, it would be 0, 0. If you were down here, it would be x2, y1, and if you were down here, it would be x3, y4, right? Now, that's lovely. We can store all of that in state, and that's the stuff we do want to store in state, because we're then going to derive how we're rendering it in isometric stuff. And this helps us with calculations about, like, you know, whether things are near things, how long things should move. Storing this in world space is a great idea. But we want to be able to convert that to what's called screen space. In 3D terms, there are some general ways of solving this using matrices that is too complicated for this morning. But we're going to look at how do we try and render this sprite on that exact spot. You can see the world space point there, but we want to get this point, that screen space point. Now, I don't really have time to go fully into the explanation of the proof of this, but generally some maths. So to explain what's going on here, the screen X and screen Y are being generated by taking the world coordinates, which are, of course, important, because you can see in here, if I'm slowly moving across, you know, if I increase in the world X, it should probably get a bit more right, but then equally, it should probably pull back on the Y, if that makes sense. And then the important thing is the... Ooh. There we go. But yes, please do, just trust me, this works. There's far more clever people than me explaining this online. The tile height and the tile width is the magic that makes this work. Because essentially, that sprite, you can see, is significantly shorter than it is wide, which gives us that compressed kind of look, where if we had a non-isometric diamond grid, it would be huge. But because it's lower, it's like that. So we times it by the tile height over 2 and the width over 2, because then we offset it by those distances. So with a little bit of maths, we can now start placing all of our images on the grid. That's essentially what we're trying to make React do. So we take that and we convert that into a little piece of code. Don't worry, you don't really need to read this. But this is basically that, where we convert from screen space to grid space and grid space to screen space. And now, OK, we're finally back in React world. We've gone through some maths and into some JavaScript, and we're back in React world, where we can take some indexes of some rows, some indexes of columns, and draw some tiles. We can get the screen position from the function previously, and then look at that. We have a terrain which is entirely built from the DOM. That's fantastic. Thank you for the one person who cheered. OK, you're not impressed. That's fine. There's more. No, no. I will earn your claps. So let's add some units on, because we want to be able to connect things and pick stuff up. So we're going to do basically exactly the same thing for rendering units, but we're going to go through our state, we're going to get the screen position of every unit, and we're going to create a div for it, where there we now have a wonderful unit. Now, because it's a DOM element, thank you, because it's a DOM element, we get stuff for free, like clicking, because you just go on click. Now I have it selected. Fantastic. I don't have to do any stuff around, you know, figuring out which sprite I'm clicking on. Now we can do, again, the same thing for buildings, where we just iterate through the building state, get the grid to screen space, and then render it. Boom. Fantastic. We now have a building. And when you click off it, there's a little event on the terrain which deselects stuff. Lovely. Now, just being able to click on things is not particularly interesting. We want to be able to make the game dynamic. We want to be able to make the game respond to what we're doing. A good place to start is scrolling. I want to be able to scroll in that direction when I move my cursor over there. So when I first looked at this, I was like, this is easy. This is fantastic. It's very simple. We're just going to get our mouse position. We're going to do a mouse move event, chuck that in some state. Then in a use effect, we'll just go, every single time the mouse position changes, can you scroll a bit in the direction that it's near? Fantastic. So I went and wrote that, and look at that, it goes left, and it kind of works, and then it stops, and then when you move up and down in a kind of like weird stroking way, you can move across to the left. This is because this bit of code around the use effects isn't working how I wanted it to, in that it's working how it should, which is only when the mouse position changes does it scroll a bit to the right. And the problem was I was trying to use this use effect like a traditional game loop. Now, pretty much every single video game in the world uses this kind of architecture, where you set up a bunch of stuff, and then you read some input, you process it, you update the state, and then you render it, and then you just keep doing that again and again and again. Now, the difference between use effect and the game loop here is use effect is obviously only changing when our state changes, and it also has no concept of time. Whereas a modern game loop will have something called the delta time, which is like how much time has passed since I last rendered, so that it can make it look smooth. So really, we want to be able to find a way to make React render more. So I went to my React book of the dark arts, and I was like, what things have I learned in my junior years where I can make things render? I could use a set timeout or a set interval to trigger a re-render. I could update a state variable on mount. I've done that accidentally a few times. And also, I could call the callback inside the use effect itself, so it's just like constantly rendering. Now, these would all like work, but they wouldn't be brilliant. They wouldn't be particularly smooth. They wouldn't run at a perfect kind of rate. Thankfully, there is a tool that is built exactly for this, which is request animation frame. This is a browser API where basically it's a way of telling the browser, oh, I want to render something. And you give it this callback. So you do window.request animation frame, and you give it a callback where it passes in the current time. Now, we don't really want the current time. We want the amount of time that's changed. Thankfully, CSS Tricks had this lovely hook pre-built for me. Highly recommend checking this article out. It goes into a lot more detail about what's going on here. But generally, we're basically keeping a reference of the request that we're doing so that we can cancel it, and then the time of the last time we rendered. So now, this callback in the center, we can do callback delta time, so I can create a method that takes in delta time, and I can do what I want. Fantastic. So if you kind of think about it, we have two ways of rendering in this application. We have a React render, which only happens on state change and props change, and is quite expensive. And then you have the browser quote-unquote render. This is much more complicated than this. I could spend a long time talking about WebKit flows and how reflows and stuff, but for our purposes, a browser render where we can cause it by request animation frame, and it's incredibly cheap. So let's use this for our mouse thing. So instead of what we did before, we'll still keep it in state. We'll set up this main loop, and we'll do a scroll if the mouse is in margin, and we'll pass it into our use animation frame hook. Fantastic. And we've done it. Look at that. Ah, wait. No, it's still not working. There's an extra thing about request animation frame which makes this a little bit more complicated, which is that position, request animation frame can't access dynamic state. It can access the initial value of state, but if we want the current value, we need to use a ref. So we switch our mouse position to being in a ref rather than in code, and now we can scroll around in a performant way. Look at that. Fantastic. So just to update that, the slight difference between that is React render, we can access all of our data, and in the request animation frame, we can only do initial values of state and current values of refs. So the tools we've kind of built so far for this project are we can convert from screen space to world space. We can smoothly animate over time now with our use animation frame hook. And we can pass state into our request animation frame callback using refs. So if we take all of those things and we have a look at the next feature, which is moving a unit. If I have a spearman standing in the bottom left and I want to move him over there, we can do a little bit of vector math where we have an X component and a Y component. And basically, we want to go from the current position to the destination. The destination we can get really easily from a mouse click event, and the current position, well, it's aligned with absolute values, so we can actually just get the top and the left value from the DOM element and not even read that from state. And then, oh, look at that, animations. So we can animate all the way along there. Now, obviously, we don't have that big, long hypotenuse there. Instead, we only have the X and Y. So we do a little bit of vector math, and we can get the distance back out. And if we convert this into a little bit of JavaScript code, it'll be able to tell us how far we're going to move. But again, we don't want to move all that way instantly. If I just punch that into a function, it would just jump around, and it'd be very good for night rushing, but not particularly for making a compelling game. So instead, we want to just move a little bit, just a tiny bit. Oh, just over there. So what we're going to have to do is normalize this vector, which means basically you make the distance equal to 1. So you make that hypotenuse equal to 1. Oh, it shows me the animation. That's cool. That's quite threatening. So we're going to scale it down to that. I have to play the animation again now. There we go. So we're going to put this into a little bit of code where basically this is a function to generate the new position of any unit that we give it. The unit, which is from state, which will have the destination where it's currently moving, and the speed of that unit, because, you know, horses want to move quicker than people, and so on and so forth. The delta time that we've gotten from our use animation frame use request animation frame hook, and then the current position of it, which we'll have gotten from the DOM element. So we can calculate the distance that we're going to go, which is just doing that little bit of vector math. We're going to square root that function. And then we get our normalized vector, where we just do the destination minus the current position divided by the magnitude of the distance. So, and that gives us the new position. So now we've done all that vector math, we would just have that unit just moving around, kind of just standing and floating about the place, which doesn't necessarily look great. But because we've done a bunch of vector maths, generating the degrees of where it's moving is super easy. So we can tell which way it's facing, and then update the CSS class on the DOM element. And now, if it moves in this direction, it'll look like that. If it moves in that direction, it'll look like this. So we've managed to build a way of moving it all around. We've managed to build those particular pieces. Should we have a look at what it looks like in person? OK. I hope the sound is working. Let me refresh. So we have here, we can scroll around. Look at this. This is all like, oh, if you go too near the top, then you can't see the feudal age. So we can select our barracks. I'm so happy that made you ooh. And we can move our unit around. Look at this. It can just move, and it knows exactly where it's going. But obviously, an army. Come on! So, obviously, this isn't the entire of Age of Empires recreated in React. We have done a fraction of this stuff. So there's still quite a lot of work to do. I'm not entirely sure whether I will go all the way and try and fully rebuild it. I'm not entirely sure that was a massive use of my time. But kind of a question you might be asking is like, can you go and play this? Can you have a look at the code? Is there a place that I've uploaded this where you can play my version of Age of Empires? No. I am just some guy, and I don't necessarily feel like distributing Age of Empires assets abroad and getting hit by a Microsoft cease and desist letter. If you would like to play Age of Empires, I highly recommend you go and buy it on Steam. There's a new HD remastered version, which is fantastic, which has great multiplayer capabilities and looks an awful lot better than that. But generally, working on this thing has been incredibly fun. Using a tool like React in a way that is entirely not designed for taught me an awful lot more about rendering performance, about request animation frame APIs, about positioning things, transitions, how to load GIFs properly into CSS, than working on any kind of day-to-day thing. So I hope that ideally, what you've taken away from this talk is that you should go and play Age of Empires, but maybe you might want to go away and create your own ludicrous thing, which might be quite nice. The main thing that you kind of learn doing this sort of project is that even if you describe yourself as a React developer, there are many other tools in our toolbox. React is not the best tool for building Age of Empires. It is also not the best tool for a large amount of things. So it's good to have an idea of what is actually more powerful in the browser space, in CSS, in our browser APIs, or just in pure HTML. Generally, this has been a wonderful time working on this stupid thing. I highly recommend you all try being really silly and dumb, because it's incredibly fun. I've been Joe Hart. I hope you have a lovely rest of your conference, and see you around. Good night. There we go.